Today what I'm going to do is introduce the law of cosines. But before I introduce the law of cosines, what I'm going to do is go through a derivation of what happens, let's say you don't have the formula. Well, the first thing we did was, when we look at this, is I'm going to first start by dropping an altitude. Well, if I drop an altitude, and if I want to find out the height, what I might say is the sine of 70 is equal to h over 10. And of course, h is equal to 10 sine 70. Well, 10 sine 70 happens to be 9.3969. Okay, so that's part one. Now for part two. Let's find the length of this piece. Well, the length of that piece we're going to use is cosine. So what I'm going to say is the cosine of 70 is equal to x over 10, I'm sorry, x over 10. 10 cosine 70 is equal to x. And after you press the buttons on your graphic calculator, you find out that x is 3.42. Well, if this piece is 3.42, we know this piece is going to be 16.58, because 20 minus 3.42 is 16.58. Let's not forget that this height happens to be 9.3969. And by using the Pythagorean theorem, we can say 9.3969 squared plus 16.58 squared is equal to c squared. C squared then happens to be equal to 363.18. And c will be the square root of 363.18, which is approximately 19.057. 19.057. Now let's look if we can figure out and derive some kind of formula from this. I'm going to use the exact same locations and the exact same numbers. Let's call this A, B, and C. Well, the first thing I did, like last time, is I'm going to drop an altitude. Let's call this H. Let's call this piece X. Of course, if this is capital C, this is small c. This is capital A, and small b. So this piece right here has to be b minus x. Now I have more or less all the information I need up to a point. Well, let's look at triangle 1 first, this triangle. We know x squared plus h squared is equal to c squared. That's triangle 1. Now let's look at triangle 2. H squared plus b minus x squared is equal to a squared. And of course I'm going to expand it, and I'm going to say h squared plus b squared minus 2bx plus x squared is equal to a squared. Now let's look at what I have. Well, I have up here x squared plus h squared equals c squared. Well, x squared plus h squared. Well, I could always substitute. So I'm going to say b squared plus c squared. C squared. So here's your b. Here's your c. The substitution minus 2bx is equal to a squared. But if you look at the original, we didn't have an x. I put in that x. So let's look at a way we can get rid of the x. Well, I do know cosine of a is equal to x over c. So I can say c cosine A is x. Well, by substitution, I can now say b squared plus c squared minus 2bc cosine of a is equal to a squared. This is now called the law of cosines. And now what I can do is take the original numbers and work it out for you. The original example, well, we can also say if a squared equals b squared plus c squared minus 2bc cosine a, we can also say b squared is equal to a squared plus c squared minus 2ac cosine b, and c squared is equal to a squared plus b squared minus 2ab cosine c. It doesn't matter which way you write it. However, all of these represent the law of cosines. Now let's look at the example that I gave you in the beginning. This is 70 degrees. This was 10. This is 20. Well, if that's the case, a squared is equal to 10 squared plus 20 squared minus 2 times 10 times 20 times the cosine of 70. And lo and behold, after you punch the buttons in, your calculations, it shows it's about 19.057, thereabouts, which is the original number we had. And that, ladies and gentlemen, is the law of cosines.